proportionality is 1 by r square. Hopefully this is clear, right? What happens to a hollow object, hollow sphere? Inside electric field is 0. On surface it is maximum yet again, and after that it is proportional to 1 by r square and becomes 0. Okay, so we'll see potential tomorrow. What we studied today, we studied gravitational fields for various objects. What is the concept of gravitational field, and what if we go above the height and below the earth by digging a tunnel of depth d? So two formulas we derived and we solved the question, and we saw due to axial rotation what happens. So hopefully this class is clear. We are going to meet in the next class. Till then, keep studying, keep imagining things, keep your curiosity on and game face on. Bye bye.
First of all, let's solve the question number 1. What is given in the question number 1? In the question number 1, it is given a process is shown in diagram which are following curve may represent the same process. Actually, in the question number 1, a PV diagram is shown here, and we have to find out which are following graph is correct for the various parameter, that T versus P versus T, and V versus T. So if we see the process, what is happening in the process AB? So if we talk about the process AB, it is very much clear in this diagram. In the AB process, our pressure is constant. Our pressure is constant. And we know that by using the ideal gas equation, that PV equal to nRT, if pressure is constant here, so we can say that the volume is directly proportional to C. So whenever we have to solve such type of graphical problem, that is basically in the thermodynamic section and kinetic theory of gases section, we have to write down the ideal gas equations and correlate the various given parameters. As in process AB pressure is constant, we can say that volume is directly proportional to temperature. So for the volume versus temperature graph in section AB is a straight line. A straight line graph. So we can say ki in which volume versus temperature graph. Let us check the volume versus temperature graph. So what we find in the option C, that is a straight line. This is the correct for the AB portion. This is something like this. If we increase the temperature, volume is also increases. Let's see the in the process BC. In the process BC, what is going on? As increase the volume, pressure decreases. So we can say that in pressure in process BC, what is going on? If volume is increases, then pressure is decreases. Such type of process where pressure and volume is inversely proportional to each other, so we can say PV equal to constant, and in this type of process we can say temperature is constant. As we see that as we moving away from the point B, volume is increases. So in the graph option C, what we observed here, first of all temperature is constant. It means that is possibility that this graph is a correct graph. And what is the second clue? As we move away from point B, that volume is increasing. This is also happening here. From point B to C, volume is increases here. So we can say on the basis of this type of analysis, we can say that BC is the correct graph for volume versus temperature, and AB is also correct. So we can say option C is the right answer for the given problem. If we check remaining option, that P versus T. So in the first option, if pressure is constant, so we can say in this zone pressure is not constant. So this is not our answer. Okay. So in this manner, we can also eliminate by elimination process. We can select the correct answer. Let's move for the next problem. In the next problem, first of all, read the question carefully. What is given here? Find the incorrect option for a given VT graph. In this problem, we have to find out the incorrect option. Sometimes student, what is the mistake done by us? we are not read the question carefully, and because of this we can not able to solve a very easy problem. So first of all, what is our role? Firstly, we have to read the question very carefully. That is given, we have to find out the incorrect answer. Okay, and here the graph that v versus t is given. Okay, so we know that ki whenever graphical problem come under the kinematics section, so in kinematics section, we know that the VT graph is the such an important graph. Suppose there are three types of graph generally given, that X versus T graph, V versus T graph, and A versus T graph. But V versus T graph is the intermediate link between the HT and AT. So we can say VT play a vital role. Okay, so how we can analyze this type of graph? We know that what is the graphical relationship whenever VT graph is given. So we can say slope of VT graph is nothing but slope of VT graph give the analysis about the acceleration. Give the analysis about the acceleration. So we can say by analyzing slope of VT graph, we can get the value of acceleration. In the same manner, if we say that what is the area of VT graph? That area of VT graph give the total displacement, then change in displacement. We can say this give the change in displacement. So here, what is given here? A to B velocity is positive, B to C, that velocity is constant. B to C section, our velocity is constant. Here velocity is continuously increasing, so we can say speed is increasing. C to D, velocity is also positive, but at point D velocity is 0. Here D to E velocity is negative. We can say E to F velocity is constant but negative. E to H velocity is decreases in magnitude. At point G velocity is again 0, and point H again it is increased to 20 meter per second. So first option, let us check the first option what is given. In A, B, D, E and G, H, velocity and acceleration have same direction. Let us pick one important concept. Whenever velocity and acceleration in the same direction, it means acceleration continuously increase the speed of particle. So this is the case of speed up. Whenever velocity and acceleration acting in same direction, we can say particle speed up is going on. If velocity is opposite to acceleration, we can say this is the case of speed down. So in this case, A, B, D, and G, H. A, B, we can say slope is positive here. If slope is positive here, guys, so what we can say that acceleration is also positive, velocity is also positive. So this is the case of the speed up. D, G, H, that is, we can say in section D, if we are talking about D, so here the slope is negative. So we can say here acceleration is negative, velocity is also negative. So this is also the case of speed up. And GH, that in the GH question again velocity is positive, slope is positive. So we can say this is the case of the acceleration. So we can say acceleration has same direction, that is the correct. But we have to pick incorrect. So this is not our answer. That total distance in A, B, C, D, E, F, G is the 600 meter. If we talk about the total distance, we can say area of this part, this part, this part. And we have know that in order to find out the distance, we have to take the magnitude of displacement. So that is the 4 part, 5 part, 6 part, and 7 part. If we add all these area, we can say this is nothing but these are our distance. So we can say what is the area of first part? That half base into height, that is the 20. What is the area of the second part? That we can say that the area of second part, that 10 into 20. What is the area of the third part? We can say that again half 10 into 20. What is the area of this part? We have to calculate the distance. We have to take positive value. So we can say this will again nothing but 10 into, we can say that 10 into half, 10 into 10, right? In this manner, we can say what is the area of this part? Positive 10 into 10. What is the area of this part? Again, we can say half this will become half 10 into 10, and this part again half 10 into 20. So in this manner, we can calculate this value, and this will become, guys, that 10 into 10, this will become 100, and this will become 200, correct? And again, this will become 100. This will again become, that is the 50. This will become again 100. This will again become 50. This will again become 100. So in this manner, we can say 100, 200, 300, 400, that is the 500, 600, and 600 plus 100, that we can say what is the distance here, that is the what is the total distance at this point, that is the 600. So in this manner, we can say that the total distance we have to calculate at point G only. What is the total distance at point H? That is the 700. But in this problem, it is asked about A, B, C, D, E, F, G. So till G, what is the total distance? In this section, the total distance, this will become 700 minus 100, and we have to calculate area till this point, that is the 600 meters. So this option is also correct. Acceleration in BC and EF is 0. BC, we can say here the slope is 0. So acceleration is 0 because velocity is constant. Again, velocity is constant. So this option is also correct. Let us check the option D. At point C, velocity of particle is changing its direction. At point C, we can say कि before point C and just after the point C, velocity is positive. So we can say velocity is not going to change its direction. So in this manner, we can say कि option D is the incorrect one. So here we have to choose the incorrect answer. By analyzing this problem, we have to know that how we can calculate the area and the slope. So in this problem, that is the option D is the right one. Let's move for the next problem. In the next problem, again, that is a very beautiful problem that is asked in the center of mass section. In this problem, what is given? That's distance of center of mass of the T-shaped plate from the point O. Here, what is given, that a T-shaped object is given, and we have to calculate the center of mass. We have to calculate the center of mass. First of all, we have to see that this is a planar object. Whenever a planar object is given, what we have to think that, firstly we have to think that suppose if this is a planar object, so how mass is written here? Suppose if we consider the surface charge density on this surface is sigma, so we can say what is the mass here? Mass is written as sigma into area, right? And sigma is the same for both the section, that is the section 1 plus section 2. Correct. So we can say that mass is directly proportional to area. So here we can say that the mass is directly proportional to area. So what is the area of the first part? That is the A1. So we can say that area that will become 2 into, we can say that this distance is 8, this is the 2. So 8 into 2, that is the 16 meter square. What is the area of the lower section? That we can say that this will become lower section area, that is 6, and this will become, we can say this distance become, that is 6 into and 2. So this area will become 12 meter square. So in this manner, we can say A1 is the 16 meter square, A2 is the 12 meter square. And if we consider O is at origin point, then by symmetry, what is the center of mass of the upper rectangular portion? We can say at geometrical center. We know that the center of mass lies for a symmetric body at its geometrical center, point where body is symmetric about that point. So we can say what is the vertical location? By observing this diagram, one thing is very much clear here, that center of mass lie on the vertical axis, that is the y-axis. What is the location of this point? We can say that 0, -1. Here, this is the geometrical center of the lower portion. So we can say what is the distance of this geometrical center from point O. So we can say this is the this distance again, that is the midpoint 3. plus 1 4 plus 1 5. So this will become, we can say 0 comma minus 5. Correct. So if we apply the formula that YCOM, we can say M1 Y1 plus M2 Y2 divide over M1 plus M2. Am I correct? What is the value of M1? Because we know that the mass is proportional to area. So we can say that the area of first part is the 16 into, we can say this will become minus 1. Again, if we want to write down M2, we can say 12 into, this will become minus 5. And here we can say this will become 16 plus 12. Right. In this manner, what we can say that this will become minus 16 and minus 60. This will become 28, and here this will become minus 76 upon 28, minus 76 upon 28. And after solving this, what we can say that this value will become, that is minus 2.7 meters. So option B is the right answer here. Let's move for the next problem. The next problem, first we have to read the problem. Two rods of copper and brass having the same length and cross-sectional area joined end to end. So one is the copper rod, another is the brass rod. So if you consider the two rods having the same cross-sectional area, and it is also given that the same length L. It is given that the free end of copper is at 0 degrees Celsius and brass is the 80 degrees Celsius. So say this is the brass and this is another rod having same length. Say this is the copper. This is our copper rod. This is our brass rod. It is given that the free end of copper is placed at 0 degrees Celsius. This is nothing but this is placed at 0 degrees Celsius and this is the 80 degrees Celsius. Okay. So in steady state, that is the very important point here, steady state. What is the meaning of steady state? We can say that meaning of steady state, the temperature of any section of rod with respect to time is not going to be changed. So we can say the rate of heat flow, the rate of heat flow, that is the dq upon dt, that is constant. The rate of heat flow, that is dq upon dt, is constant. And in this problem, it is asked about the junction temperatures. We can say if junction temperature is T, we have to find out the value of T. Guys, one thing also given that the thermal conductivity of copper is the 4 times of brass. So suppose if the thermal conductivity of brass is K, so what is the thermal conductivity of copper? That is the 4 times K. Just apply the condition of the steady state. We know that what is the heat flow rate due to conduction. So if we write down the equation, heat flow rate due to conduction. So what we can say that if we write down this formula, what is the heat flow by conduction, guys? So we can say that this is nothing but dq upon dt or delta q upon delta t. We can say that Ka T1 minus T2 upon, we can say that is the length along which heat is flowing. So what we can say that this is equal for the both the section. This is equal for the both the brass as well as copper. So here we can equate the heat flow rate. So we can say this is nothing but K brass is same for both the rod, and we know that heat is always from higher temperature to lower temperature, and this is our junction temperature. So what we can write down here, that Ka, guys, K into A, 80 minus T, that higher minus lower, and that is the length L. K, and we again say that is the thermal conductivity of copper, that is the 4 times of brass. We can say 4 times Kb, area is same, and this is the junction temperature T. Again we can say this temperature is 0 and length is always again same. So here what we can say, Kba is cancel here, that 80 minus T, this can be written as 40, and the value of height T equal to 80 degrees Celsius, where we can say the temperature of junction is nothing but that is the 16 degrees Celsius, that is the 16 degrees Celsius. So option D is the absolutely correct here. Why option D is correct here, guys? We just apply the equation. We just apply the equation and see the result. What is the answer? And what is the equation? That is the steady flow rate conduction. At steady condition, what is the rate flow of conduction? Let's move for the next problem. Again, what is given in the next problem? This is the problem that is come from the meter bridge section. And in this problem, guys, what is given here? If we read the problem, the null point is found at a 25 centimeter from A. This is this is a point A, this is a point E, and if this is a meter bridge, so we can say what is the total length, that is the 100 centimeter. This is the absolutely correct. We can say that here total length is 100 centimeter. This is the basic information that we know that from the meter bridge. And it is said in the problem the null point is obtained at 25 centimeter from A. So we can say if the first null point is obtained, you say this is the 25 centimeter, then what is the remaining distance? This is the null point condition, guys. Say here the galvanometer deflection, so the reading 0. So this is the 75 centimeter. So what we can write down about the information given in the first condition, that R upon 25 and S upon 75. Am I correct, guys? S upon 75. So what we can say that, guys, about the using of this information, we can say that what is the value of S here. So we can say the value of S equal to 3R. Say this is the equation number 1. Let's read the problem. What is given in the again point. If a now a resistance of 10 ohm is connected parallel with S. Again 10 ohm is resistance that is connected with parallel to S. So what we can say that in this condition, if you want to draw the circuit diagram, we can say this is our resistance R. And what is the net resistance of this section? We can say whenever two resistors are connected in parallel, one having resistance S, another is 10, then what is the equivalent resistance? That R1, R2 upon R1 plus R2. Am I correct? We can say that this will become 10S divided over 10 plus S. So this is the resistance of, that is the second branch, 10 plus S. We can say 10S upon 10 plus S. And this is R, correct. And we can say in this condition, the null point occurs at midpoint. We can say here, we can say this is our midpoint. So we can say what is the midpoint? That 50 centimeter and 50 centimeter here. So if we apply the balance condition, that is the balance condition of the WB in the second case, what we can say that if R upon 50 and this will become 10S, that 10 plus S and divide over 50, correct? So here we can cancel out 50 from here, and we can say that if we put the value, that what is the value of S? 3R, correct? So if we put R equal to in the place of S 3R, this will become 10 into 3R, that will become 30R, 10 plus 3R, right guys? So if we solve this equation, so what we will get here, guys, we can say that 10R plus 3R square, this will become 3R square 30R. If we take the R common, so what we can say here, this will become, we can say R and R is the simply cancel out from here. So 10 plus 3R, this will become 30 and 3R will become 20. So value of R will become 20 by 3. This is nothing but 6.67. There is no need to do this. We can simply cancel out R from here. So this is the basic problem, that is the based on the concept of the balanced WB, that is the balanced Wheatstone bridge. And how we can solve the problem, how we can approach the problem. One thing we have to know, what is the basic information, what is the meaning of meter bridge, and what is the meaning of null deflection. Okay, I hope this is clear. to everyone. Let's move for the next problem. The next problem, guys, that again it is a very good problem that is asked from the AC section. In the electrical RLC section, it is given that the AC source are connected in series. So we can say ki in this problem R, L and C, all three elements that are connected with the AC source in series. Okay. When L is removed from the circuit, suppose this is R, this is C, and this is the L. When L is removed from the circuit, so it is given that the phase difference between voltage and current in the circuit, that is the pi by 3. Okay. So if according to condition, if we remove L from this circuit, so this will become R and C, and this is the AC board, correct? So in this case, we know that what will happen here. If this is the phase that we consider that this is the phase of the current I and this is the resistance R, and if we consider that this is the phase angle that is made by the impedance triangle, and in this condition, if you want to consider that what is the tan phi in the series LCR circuit, that is always written in this manner. We know that XL minus XC upon R, that is in magnitude, right? So in this condition, this formula is always valid for series LCR circuit. But in this problem, it is given that when L is removed, we can say tan phi equal to XC upon R. And it is given that the phase angle in this condition that phi equal to pi by 3. If you put this value, this will become tan pi by 3, right? Tan pi by 3, this will equal to x by r. Tan pi by 3 is nothing but, guys, this is root 3. So what we can say, xc upon r equal to root 3. What is the value of xc? That root 3 into r. Say this is the equation number 1. Correct. In the second condition, C is removed from the circuit and phase difference again become pi by 3. If we again using this equation, and in this case, it is given that C is removed, we can say that if again C is removed, the circuit will become RL circuit. Correct. Circuit will become RL circuit. Only two elements are present here. So what is the new phase difference? That tan phi. Again, we can say apply the formula that XL minus XC upon R. Here it is given that what is given that, guys, that C is removed. We can say this will become XL upon R, and phase angle again given at pi by 3. We know that tan 60 again written as root 3. So XL become root 3R, right? So what we can say that we find out the value. If the C is removed, we can get the value of XL root 3R and XC is again root 3R. Correct. So what we can say that, guys, if we know the value of XL and XC, can we tell about what is the power factor? So what is the power factor, guys? Power factor is nothing but cos phi, and this is written as R by Z. So we can say R, and what is the Z? Z is nothing but XL minus XC square plus R square. In this case, XL and XC is equal. So we can say this value will become 0, and this is nothing but the case of the resonance. We already know that. What is the value of cos phi here, guys? That is R upon, if this value will become 0, R upon R, and this value will become 1. So we can say what is the option correct here? That option A is the correct here. And in direct form, it is given that information. This is the condition of resonance where value of XL equal to XC. Let's move for the next problem. This problem, that is the application, we can say that the application of the EMI portion. A step down transformer reduce the voltage of transmission line for 2200 volt to 220 volt power delivered, that is the power output, right? And the efficiency, that is the 88%. Again, that is very important problem, because in this type of problem that is generally asked in the JEE main and NEET section, because in this problem efficiency is given. It is not tell that efficiency is 100%. So we can say 100% power input not converted into power output. That 12% energy is lost in the any form we can say eddy current losses, heat losses, that is given in the problem. That is not the part of our discussion, but we know that only 88% efficiency means 88% energy is utilized. Okay, so what we can say that here directly that power output is given that 880 watt, correct. And firstly, we have to find out what is the power input. If we know the what is the power input, then we can write down the formula. Power input is nothing but V into I. And we know that what is the value of input voltage that is given in the problem. That input voltage that is given in the problem 2200, right? So firstly, we have to write down the power input. How we can get the power input? That is the very easy. We can say the power output is nothing but that is 88% of power input. Correct. And what is the value of power output, guys? Power output is the 880. Here we can say that this can be written as 88 upon 100. Okay. And this will become power input. So here we can say that this value will become power input will become 1000 watt. Power input will become 1000 watt. So if we put this value here, say this is the equation 1. So 1000 equal to 2200 into I. I nothing but that is the primary current. That is the current in input section. That is the primary current. And that is asked in the problem that input current that is 1000 upon 2200. And we can say that this value will become 10 upon 22. That will written as a 5 upon 11. And if you solve this, this will become 0.4545 ampere. So option C is the right one. I hope this is clear. That is a very, very important problem. And that is a simple formula that is governed that power equal to V into I. If efficiency is involved, then we have to write down the formula in this manner. Suppose efficiency is 100%, we can say power output is equal to power input. The next problem that is asked that is the wide AC section, and what is given in the problem. If we see the problem, the intensity of central bright fringe that is the 8 milliwatt per meter. This is the intensity. This is the intensity given, and what will the intensity that lambda by 6? Actually, this is the meter square. What is the intensity that lambda by 6 path difference? So if we talk about the wide AC, firstly we have to know that what is the intensity at the central bright condition. So if we talk about intensity, what is the intensity at central bright condition? Firstly we have to know that this intensity that can be written as 4I naught cos square pi by 2. This is the value of the intensity. Okay. So here what is given that the phase difference is given, and if you want to find out the intensity, then we have to apply this formula, and for applying this formula we have to know the value of the phase difference. How we can relate the phase difference and path difference? That is the beautiful relation. Delta phi equal to 2 pi lambda into delta x. This formula again we know that, so we can say that delta phi, that is we have to find out here. We can say this will become 2 pi upon a lambda. What is the value of delta x here, guys? That lambda upon 6. So we can say here this value will become pi by 3. If we put this value here, so what is the value of I? That is the 4I naught cos square. This will become pi by 3 by 2. That is the pi by 6. And we can say that this is the value of the central bright fringe. That is the maximum intensity that is given in the problem. That is 8 milliwatt per meter square. And we know that cos pi by 6 means we can say this value can be written as root 3 by 2 whole square. So if we solve this value, what we can say this will become 4 into 8, and this will become 3 upon 4. So in this manner, we can say that what is this value? So we have to find out what is the find out here. What will the intensity of the path difference? Okay, guys. So here the option that 20 milliwatt per meter square. That is the right answer. That 24 watt per meter square. Let's move for the next problem. In the next problem, what is given that two radioactive substance that is given that their half-life period is also given. And what is the half-life period? That is 1 years and 2 years. That is the half-life period is given. So we can say the half-life period. If we say the half-life period that we represent by the capital T. What is the value of half-life period here, guys? That for the substance A, TA, 1 year. And what is the half-life period? That is the TB. This is the 2 year. Correct. So this value will become, we can say that this value will become 1 year and this value will become 2 year. What is the equation that is governed in the radioactive substance? We can consider it the original amount of substance, that is N naught. After some decaying, after some time, the remaining amount is N. So what is the equation? We can say this equation can be written as that N naught, and we can say that this equation, if you want to convert in the form of direct in the logarithmic equation, that N equal to N naught, that 2 raised to power, guys, we can say T upon this is our nothing but that is the half-life period, that is TH. Okay. So this is the equation, that is the amount remaining after time T, where T half is the half-life period. T half is the half-life period. So what we can say that here, guys, this value will become for the substance A, that we have to find out the ratio of number of undecayed atoms of A to undecayed atoms of B. That is Na upon AB, right? So N naught is the original amount. That is same for the both the case. We can say this value will become N naught 2 raised to power. What is the total time? That is the 4 years. Here the total time is given, guys, that is the 4 years. What we can say that this 4 years is taken here. What we can write down here, this will become minus 4 upon 1. Again N naught 2 raised to power and minus 4 upon 2. N naught, that is the cancel out from here. So what we can write down here, guys, that 2 raised to power minus 4, and this will become 2 raised to power minus 2. We can say this will become 2 raised to power 2. So what is the answer here? 1 by 4. We can say answer 1 by 4. That option is the correct answer here. That option is the right one, guys. So in this manner, what we can say that the option is the right one. In the next problem, what is given? A mass is suspended separately by two springs having spring constant K1 and K2 successive order, time period of acceleration that is given T1 and T2 respectively. So suppose there are two individual springs. If we consider that this is the spring 1 having the spring constant K1 and this is connected with a block M, the same block. And the another situation where the another spring that is again connected with the same block having the spring constant K2, right? We have to establish a relationship with, if relationship between the T and T1 and T2, say in this case the time period is T1, in this case the time period is T2, and the time period of the system of the K1 and K2, that is T. So what is time period? We can say that, guys, what is the relation here? If you want to write down the time period, we know that the time period is written as 2 pi root over m upon k. I hope this is clear. If we squaring both the sides, we can say t square. This can be written as 4 pi square m upon k. So what is the value of k here? The value of k, this can be written as 4 pi square m upon t square. We know that, guys, 4 pi square m is constant here, and this is the k of the system. These two springs are connected in parallel, and when two springs are connected in parallel, we can say k is nothing but k1 plus k2. If k is nothing but k1 plus k2, guys, so what we can say that this can be written as 4 pi, mass is same here, that is T square. What is the value of K1 here? K1, this can be written as 4 pi M1 upon T1 square. What is the value of K2 here? 4 pi M upon K2 square. Put the value here. We can say 4 pi M upon T1 square, 4 pi M upon T2 square. So here 4 pi M is cancelled out from numerator, that T square 1 upon T1 square plus 1 upon T2 square. We can say that after solving this, we can say T raised to power minus 2, T1 raised to power minus 2 plus T2 raised to power minus 2. Option B is the right one. Let's move for the next problem. What is the next problem that is given here? If we read the next problem, that is the helium nucleus is given here, and it is given that helium nucleus is produced by fusing two deuterium nuclei, guys. Here the deuterium nuclei is given. We have to understand that the deuterium nuclei, what is the meaning of deuterium nuclei? We can say this is nothing but isotopes of hydrogen atom at 1H2. This is known as the deuterium. That is the basic information. If we know about this problem, we are going to solve this problem. We have to know this. What is the meaning of deuterium? And this is say that after combining 1H2 and 1H2, a helium nucleus is produced and some energy that is the form of the Q energy is generated here. So we have to find out the value of Q energy. So basically, what is the Q energy, guys? If we talk about the energy released, RQ value, or we can say energy liberated. This is nothing but we can say ki energy that we can say here ki energy of this reactant minus energy of product. Correct. So we can say that this can be written as these are the identical atoms. So we can say that this is nothing but the energy of this energy. This can be always written as delta MC square. That is the Einstein equation we noted. And what is the value of delta M here? We can say, guys, this is if we consider the mass of 1H2, that is the M. This will become 2M. Okay, 2M times mass of the deuterium atom minus times we can say what is the mass of this atom. Consider the mass of this atom with the capital M. We can say mass of the helium nuclei. Okay, and we know that this energy, if we consider that one for the 1 AMU, if the mass defect is the 1 AMU, then what is the value of binding energy or Q value? That is the 931.5 mega electron volts. We can say ki what is the binding energy or Q value corresponding to this amount of mass, that is equal to 931.5 and mega electron. If we put the value of what is the value of deuterium mass of nucleus of deuterium, we put the value here. We can say 2 into this can be written as 2.0149. And what is the value of the mass of the helium nuclei? This can be written as 4.0027. And we can say that this is the value of helium nuclei. After solving this, what we will get here, we can say that 930. After solving this, we will get 25.24 mega electron volt. Option B is the right one. Let's move for the next problem. What is given here? Comparing LC circuit and spring block system. Which physical quantity is similar to M by K? Just compare this. What is the, if you write down the omega in the spring block system, so this can be written as K by M, right? If you want to write down the frequency in the LC circuit, this can be written as root over 1 upon LC. We know that what is the role of K? K that store energy in mechanical form. Spring stored energy in mechanical form. The same role is C. Correct. The same role is C. We can say by comparing this, we can say that K is nothing but 1 upon C. Okay. And here mass is equivalent to L. So we can say what is M and K. So M is nothing but L and K is that is 1 by C. Option D is the right one. Object is 20 centimeter away from concave mirror having the focal length 15 centimeter. If the object moves the speed of the 5 centimeter per second along the principal axis, then the speed of image will be. What is the speed of the image? We know that the speed of image with respect to mirror, this can be written as magnification square, that speed of object with respect to mirror. Right, guys? So firstly, we have to calculate what is the magnification. That is the magnification. This is written as minus times v square e square, v square u square, and v, that velocity of object with respect to mirror, guys. So what is given, guys, here? If we put the value, firstly we have to calculate the image position. Firstly we have to calculate the image position. What is the image position here? If we calculate the image position, or we just directly calculate the magnification, then we have to know the relation that magnification is nothing but v by u minus times, and this can be also written as f upon f minus u, correct? Because if we apply the lens formula 1 by v, the mirror formula 1 by v plus 1 by u equal to 1 by f, after putting the value, we can directly put the value in the form of focus length. And whenever we are going to appear such type of examination, we have to already cover this type of formula because of the saving the time. So we can say what is the magnification here, that can be written as minus 15 and minus 15, and this will become plus 20, and this will become minus 15 upon 5, that is minus 3. If we put minus 3 here, that will become, we can say that minus 3 square, and this speed that is given that 5. So in this manner, we can say that minus 45. And what is the unit? That is the centimeter per second. Here we have to find out the speeds. We have to take the magnitude, that is the 45 centimeter per second is the right answer. I hope this is clear. So what we learn from this problem, we have to directly remember this formula by using these two formula. Right, guys? So let's move for the next problem. This is the problem that is the asked from the diffraction section. Here the single slit, that the width of the single slit is given, and we have to find out the distance between the first dark fringe. What is the distance of the first dark fringe, guys? We have to know that what is the distance of the first. If it is the center of right, we can say this is the distance between the first dark. Here the first dark fringe is formed. We can say this is the distance between first dark fringe. Okay. So what is the distance here? We have to know that what is the distance here, what is the distance here. So we have to know the formula here. What is the formula? This distance can be written as that. We have to very much clear about this formula, that 2d lambda upon, if we consider the slit or the distance of the slit, that is the small d, that is 2d lambda upon d. This is the distance between the first dark fringe. So if we put the value here, 2 into what is the value of capital D here? This is given that 2 meter apart from the slit, that 2 meter, put the value of 2 meter, put the value of lambda here, that 600 in nanometer, we have to convert in meter. And if we put the value of 1 mm in meter, what is this value? After solving this, 6 to the 4, and we can say that what is the value that will come here after solving this? That is the 24, and we can say after solving this that 24 into, we can say this value become 2.4 after cancel out this minus 3 meter. So here we can say 22.4 m is the right answer. What is the concept? We have to know that that center, that is the bright fringe is formed, that is the center bright after the first dark, that is symmetric upper and lower end. We have to find out the distance, this distance, and we know that this distance is nothing but 2d lambda upon small d. So let's move for the next problem. Option D is the right answer here. In this problem here, the graph of velocity versus x is given, and we have to draw the acceleration displacement graph. So this is a straight line graph. If somebody asks to write down the equation of this graph, so we can say this is the simple y equal to ms plus c. So in the vertical axis, velocity is given. What is the slope here? We can the negative minus v naught upon x naught. And what is the y-intercept? That is the v naught. This is the equation. And the relation in the option that is given between the a and x, and we know that what is the relation between a and x in the acceleration format, that a equal to, we can say, v dv upon dx. So if we differentiate this equation, what is the dv upon dx here, guys? This can be written as dv upon dx. If we differentiate this equation, we can say this will become minus v naught, and what is the differentiation of this function? This will become minus 1 upon x naught square. And what is the differentiation of v naught? This will become 0. So we can say that here, what is the in this, that is the, in place of x we have to write down, guys, x here. So what is the answer here, guys? If you write down the answer here, so if you differentiate this function, so what we can say, dv upon dx, this will can be written as, this can be written as, say here, differentiation of v naught upon x naught, differentiation of x is 1 and v naught is 0. This is the value of dv upon dx. Put the value of v here, a equal to value of v minus v naught x plus v naught, and dv upon dx, that is the v naught upon x naught. After multiplying this, what we can say, this will become minus minus plus v naught square upon x square, that is the x plus v naught, and minus, this will become minus v naught square upon x naught. So after comparing with the straight line equation, we can say this is the value of slope, which is positive. This is the y-intercept, that is the negative. Correct? So in this graph, between the graph a versus x, slope is positive and c is negative. We can say here c is negative, but slope is positive. But option C, in the option C, what we observe here, what is the value of this slope? If we talk about what is the value of slope we want here, that we want slope positive and c negative. We want slope positive and c negative. So in this manner, which one graph is the correct here? If we say that we want, if we compare this equation, where slope is positive, it means theta is acute angle. So in this graph, theta is acute. This is obtuse. This is not our answer. This is not our answer. But in this graph, what we can say, here theta is acute, slope is positive, y-intercept is negative. Most appropriate answer is option B. In this problem, force is given and we have to calculate the power developed. We know that the power developed, this can be written as F dot V vector, correct? And here force is given, we not know velocity, but one information is given, mass. So here we can calculate the acceleration, that force upon mass. So what is the value of acceleration? That 2t I cap plus 3t square j cap. And if acceleration is known, we can say dv upon dt. So what is the 2t I cap plus 3t square j cap? What is the value of dv here? If we integrate this, again we will get 2t square 2 I cap 3t cube 3 j cap. And if we take initially particle at rest, we can say 0 to v, and this will become 0 to t. What is the velocity, guys? We can say t square I cap 3t cube j cap. Put this value here, what we can say, 2t I plus 3t square j. If we multiply this value, t square I plus 3t cube j, what is the answer here, guys? We can say this value will become 2t cube plus here. What we can say here, this value will become 3 and 3 cancel out. This will become 1, 3t raised to power 5 watt. Which option is correct? Option D is the right one. In this problem, a rod is hinged at its axis and rotated by applying a constant torque. So what a constant torque means, we can say torque is nothing but I into alpha. If this is constant, what is the value? That T upon I. And initially body is in rest, we can say what is the angular velocity at initial condition 0. The power developed by the external torque as a function of time. Guys, we know that, guys, if alpha is constant here, then we can apply the equation omega equal to omega naught alpha t. Omega naught is 0 here. Omega, this can be written as alpha into t. We can say that alpha, this can be written as nothing but T upon I into T. Correct. So here we have to find out which one graph is the correct graph. So what we can say, this represent the relationship between, that is the relationship between omega versus T is the straight line, but we have to find out the value of power. What is the power? T into omega. If we put this value here, we can say T into T upon I into capital T, power equal to T square I into small t. That it is given that T square I is constant, we can say power is directly proportional to time. We can say straight line graph is the correct answer, but non-zero slope. Because T square I is a non-zero value, so we can say option B is the right answer here. In this problem of polyatomic gas is given at the 6th degree of freedom. So in this problem, we have to calculate the value of heat given to the gas. And we know that applying the first law, that delta Q is written as that delta U plus W. Correct. And if gas is ideal, we can say PV equal to nRT, and the heat given at constant pressure, this can be written as NCP delta T. Correct, guys? And this is given in the problem. The process is proceed in constant pressure. If we differentiate this equation by with respect to constant pressure, so what we can say that if we write this at constant pressure, this can be written E delta V and R delta T. Correct? And we know that what is the work at constant pressure? E delta V. This can be written as N R delta T. Right. Here work is given that N R delta T is given 25 joule, and we have to calculate the value of Cp here. We know that what is the value of Cv? That is Fy2R. We can say for the degree of freedom, that is 6 is given. This will become 3R. Cp minus Cv from Mayer's formula, that is equal to R. So what we can say, what is the value of Cp, that is the 4R. So here we can say that, guys, that delta Qp, this can be written as N in place of Cp, that 4R delta T. Correct. So say this is the equation number 1. Delta Qp, this can be written as Nr 4 times Nr delta T, and Nr delta T is equivalent to 25 joule. So we can say heat given at constant pressure, that 4 into 25, that is nothing but 100 joule. So option, we can say option A is the right answer. In the next problem of proton and alpha particle, that is initially separated at a distance r. So we can say this is the proton and this is the alpha particle. Initially, they are separated at a distance r, because if we consider the initial condition by some and how they are keeping at rest, and we can say we know that what is the charge of proton, that is the E. What is the mass of proton, if we consider m. What is the charge on alpha particles, we can say 2e. What is the mass, that is the 4m. And after, if we free the proton and alpha particle, what will happening, right? They are moving because they feel a Coulombic force having the same nature of charge. Say the velocity is v1 and this velocity is v2, and it is given that after some time, suppose this is the condition of proton and this is the condition of the alpha particle, that is the 4m 2e, and they are at a large distance. We can say this distance is r2, is tending to infinite. We know that if there is no external force along the line, we can conserve the momentum. So initial momentum equal to final momentum, and we know that what is the value of initial momentum. If we consider that is zero, so final momentum must be zero. If we taking rightward direction is a positive direction, what is the final momentum of alpha particle? That m into e or m into v2. We know that this particle, because of the electrostatic repulsion moving in leftward direction, what is the momentum of this particle? That is the m into v1. So here we can say that m and m cancel out. If we separate this, and we can write down here, guys, v1. What is the value of v1? That 4 times of v2. Say this is the equation number 1. We know that if there is no external force, electrostatic force that is acting here, that is an internal force for the system. We can apply the conservation of momentum also. If we apply the conservation of momentum, and conservation of mechanical energy is also valid here. This is come by the conservation of momentum, and this is come by conservation of mechanical energy, that u initial k initial equal to u final k final. So initial condition, they are separated at distance r. So there is a system create a potential electrostatics potential energy. This can be written as 1 upon 4 pi epsilon. That is charge, product of charge, that is E into 2E, and distance between two charges are. Okay, initially they are rest, kinetic energy of the both the particle is zero. And finally they are at a distance, large distance. We consider that distance infinity. Again, the potential energy will become zero. And we can say the velocity at that is this instant. Sorry. If this velocity is v2, this velocity is v1. Correct. So what is the kinetic and potential energy? That half. We can say this will become half. This velocity will become half mv1 square half. What is the value of velocity of alpha particle? That is v2 half v2 square, and mass is the 4m. Alright. So if we solve this equation, we can say that half m. In place of v1, we can put the value 4v2, and this will become 16v2 square. Again, half 4m v2 square. Right, guys? And this can be written as 2e square upon 4 pi epsilon naught r. If we solve this value, what we can say that we have to find out the kinetic energy of the alpha particle, and this can be written half into mass, that is the 4m, into we can say v2 square. So we can say in this term we can take the common half 4m v2 square, and if we take common from here, what we will get remaining term here, that we can say that this will become we can say that half 4m square. If we take common here, we will get here, that is nothing but 4 plus 1. This will become 4 plus 1, and this will become, we can say 2e square upon 4 pi epsilon naught r. 4 pi epsilon naught r. If we guys solve this, what we will get here? If we solve this, we can say that this 2 and 4 cancel out. 4 plus pi, this will transfer here, and this is nothing but kinetic energy of alpha particle. We can say E square, and this will become 10 pi epsilon naught r. So in this manner, we can say option D is the right answer. These are the some most important question that is asked in the test. I hope this video is